Alright, hello everyone. Today I'll be showing you this spaceship generator script that I made, and I'm going to show you guys a little bit of how to work it, some applications for it, and pretty much what you can do with it. It's a pretty cool script that just creates these shapes, these forms that you're seeing here. It's kind of like a spaceship, and it's fully generative. So it means that when I say generative, it means that you can make infinite different options based on these parameters that you see on screen. This is kind of the whole script right here. The thing that you're looking at right here is the whole script. I'm going to go a little bit over how it works, what it does. You can get it in the MetaRx shop. So if you go into the link in the description, you can find where to buy it. It's not expensive at all, so it's for a very cheap price. You can get to play with this script and generate different forms, for whatever project that you're using. It could be just for 3D modeling, it could be for architecture, it could be for design processes, it could be for VFX, anything that you want to generate these forms for. It's pretty useful. Even though it's a spaceship generator, it has kind of very general applications because it's just a form finding generator pretty much. So you can use it for whatever the hell you want. So pretty much I'm going to go over how does the script work. I mean, you can read through all of this the moment you download it. This kind of just gives all of the steps and what everything is doing, just so you have a better understanding of how it works. And if you want to create a generator similar, then you could kind of, based on these explanations, you kind of see how you can create it. But pretty much the very basics is that it's using a layering logic, and then it's randomizing points in those layers that are being connected, and then based on those connections, you're getting a form that's somewhat novel, and it looks somewhat cool. And so pretty much it starts creating the layers here. If we look at the primitive, it's this shape, stretch sphere, which gives you the ability to then create these layers. And then from those layers, we're creating all of the other elements that are joining with each other. So in this case, we have these shapes. And then from these shapes, you're getting these lofting things. So you pretty much are getting these forms that are connecting with each other. And you're doing that for that. And you're also doing it for the inside part, which is a different kind of flow that's getting remeshed into a bunch of lines, right? It's getting remeshed into these lines that are eventually meshed into the overall volume that you're looking at. So it's a cool process. Let me hide all this just so we can go through the parameters. Let me turn this one on, right? So you can pretty much see these are all of the parameters. This pretty much works with the scaling of the form. The first scaling is kind of a minimal scaling tool. It just kind of scales it out, but it doesn't affect it as much as the scale 2. So when you increase the scale 2, you're gonna see how it gets really fat. It doesn't just make it bigger; it just fattens the primitive shape, and that way you get a more fat form. If for any reason you would want to make it that way. So you see how it just kind of bloats it a little bit. And if you reduce it a lot, it's going to make it really slim, which can also be useful. But I'm going to keep it at the basic, which is 0.15. Actually, 0.20 might be better. And then the other scaling tool, it also just, it scales it in a different way, a little bit more dynamic. And, at some points, it can break that exterior form. So the width is pretty much how connected are these two mirrored elements, because as you can see, this is pretty much 1 and 2. So if I reduce that, they're going to get more separated. Actually, no, they're going to get more together, right? They're going to be put together. And as I increase it, we're going to get more separation, right? So they're going to be more separated. And if you max it out, they're going to be very far apart from each other. Just the external shape, which again might have its application for whatever reason you want to make it. Complexity, it's a cool one. This pretty much just adds complexity in the whole thing. Zero will break it, but if you do 1, for example, like in this case, you might break the form, but you get more simple shapes, right? And then you can also play with the seed, which the seed pretty much just changes the whole thing. It generates completely different forms. But it's seed 2 that does the most of it, right? Seed 2 affects it the most. And then seed 1 is kind of a small iterative seeding. I guess this one is staying very similar. So, I mean, we can always increase the complexity so you can get different forms. And if you increase it even further, you're going to get really complex shapes that start looking cool. And when you get to really high complexity numbers, you're going to get something that looks kind of like a transformer. You need to give it a second. Yeah. So you see, like, you get more of these kind of really crazy forms. 16 max. The only thing is that when you increase the complexity, the script is going to go slower. So it's just going to take a minute to show you the iterations, which if you want to play around with, the best thing is to turn these off. So you can turn these off. I should have these on. Right. Okay. This way you can iterate through different forms without having to wait so much. Even it's still slow because it's very complex, but you can kind of see the representation a little better. So, okay, but we're gonna reduce the complexity just because we don't want to deal with those things. But you know, for example, if you keep it not that complex, you're gonna see how you can iterate a lot faster. And maybe I'm gonna increase the scale a little bit just so we get something different. And I'm gonna turn this back on just so we can visualize it. Right. When you go to shifting, this is pretty much how it's being shifted. Because when you look at it like this, it could be flat or it could be shifted. And then the shifting direction is pretty much where it's shifting. So you see how it's like being inclined. And if you reduce the X shifting amount pretty much inclines it from the top. So when I increase it, you're going to see how it gets like sharper in a specific direction. And, you know, it creates kind of a more... Let me change a different seed because I'm not really liking this one. And, okay. I mean, I'm just trying to have a cool one to show while we kind of iterate between the parameters. But I think it's also kind of fat. It should not be this fat. I'm going to reduce it to 0.15. And this scale, I'm going to increase it to 50 or 0.50. It's kind of a sweet spot. Okay, now we're getting something more that I think will be good. Now you can affect the interior part of the form, which can be the inner skeleton kind of. You can change its size, which doesn't affect much. It changes it. I mean, if you pay attention to these, it's actually changing the way it looks. So it gives you some freedom. You can also change the position, so you can also separate that part. Just kind of just separates that inner skeleton. And as you separate it or join it, it'll merge with itself, and it'll work fine. You can also change the seed. So the seed pretty much changes the whole inner skeleton form too. Kind of the size and the seed. These two seeds affect the most of it. So you can always just get a different inner form. And then the complexity. It's kind of like the other one, but only for that inner part, only for the inner skeleton. So when you reduce it, you kind of get a very simplified form of that, which can be useful if you need something more simple. You see? So let's just leave it somewhat complex because it looks cool. Now this is pretty much just the mesh radius. So if you wanted this part to be thicker, if you wanted to have thicker forms, you can always increase the mesh radius. It's just going to get a lot blobbier. So you want to be careful because then you lose some of that form. This pretty much if you want to 3D print it and you don't want those very thin lines, you might want thicker lines so it can be 3D printed, just affect the mesh radius. But if you're not planning on 3D printing it, keep it thin because it looks cooler. You can also change the smoothing, which will smooth it out more, but eventually it breaks. You see how it has the break-in? You can always increase it so it looks more organic. I feel like 3 is kind of the sweet spot, so I usually keep it at 3. And the smoothing type, I mean, doesn't really change much. Honestly, out of all of these, the best one is this one. I'm not sure how to. Well, Gaussian can be cool too, but it makes it kind of like, you see like this. If you don't smooth it, then Gaussian can be actually interesting. Yeah, you can actually make something cool with Gaussian. It just makes it look a lot more organic. So actually I like this. I'm gonna make it 1.25, no smoothing, and Gaussian. But if you want to do this one, Laplacian, I'm not sure how to say it, but for this one you might want to smooth it out a bit. But for Gaussian, you don't need it to smooth it out. You get something more organic. And I think actually you get something that's a better mesh, but we'll see. Then exoskeleton, this is pretty much the outer skeleton. You can also change the ends. So actually this shouldn't be called exoskeleton, it should be ends. Or actually exoskeleton ends. So what I mean by that is this, the ends. You see how like it ends at these points right here? You can pretty much change that and affect that, because at some points you might want it to look more, I don't know, you might want it to have a different ending form. So for example here you can affect that. You have all these seats to go through, and you can find different way where it ends, where it makes more sense, where it looks cooler. You can also offset it more or less. So if you reduce the offset, pretty much offsets the way, it just changes them further so you can have more control. And then the part separation, it's pretty much, as you can see, how much these ends are separated from the other. So you can play around with these just to have a better form that you're looking for. And you can also change the angling of these, which is somewhere here. Okay, here. And the shifting part, you can also, actually this should be here. This should be here. And then it should not be here. Okay. Sorry about that. You guys will get this fixed script, so don't worry. But you can also change the angle from these ends. So now you currently, as you see them, the ends are kind of angling inwards. But I can also change the way they come together. And so I have more control over that with this. Which again, you can just get completely different forms with that. So that's pretty much the whole script. It's kind of a pretty straightforward video, but you see that you can start playing with some of the forms that you're getting right here. So you can see, you just got to keep going with the seeds, with the scaling, everything, until you get something that that you might like or enjoy. In this case, I'm going to increase the complexity a bit, just so we get something that's cooler. And I'm also going to change the seed of the ends, just to find something different, and also reduce this. So we get, when you reduce it, you have something that kind of ends more like that. And this is looking like a spaceship, actually, like sometimes they don't look like spaceships, but in this case, I think it looks quite like one. I'm also going to reduce the mesh radius a bit. I'm gonna keep it at 0.25, and just maybe reduce the complexity so you can see it a little better. And now you get really cool forms like this. And so for example, you can bake this. So as soon as you can also change the color. I mean, just so there's a little bit of customization, but just keep it white. And then here you just click on it so it bakes, so you don't have to do much. So now it's on Rhino. I'm gonna turn off the turntable. I can just select it and it's on Rhino right now, as you can see, right? If I'm going to shaded view, you're gonna see how this mesh right here, it's somewhat, it's not perfect. I mean, it's kind of messy. So for example, I'm gonna isolate this. If you wanted to just affect this form and kind of maybe play around with it better, I suggest you do quad remeshing. So you can select the shape in Rhino and then just do quad remesh. Make sure you have a high target quad count, because the smaller it is, the longer it's going to take to compute. So I mean 10,000 usually should be fast enough. So let's leave it at 10,000. I'm gonna mirror in Y, so I'll make sure that it stays like this, and I'm gonna make it a sub D. So I pretty much get that. Smoothing that I'm looking for. And so it's gonna take a minute. I'm gonna skip probably through the remeshing. If your computer it's more powerful, then it probably will do it faster. If not, then I mean it's completely fine. Just give it a wait. Oh, it actually did it faster than I thought. So I think it's also because the Gaussian. So when you do the smoothing type Gaussian, it takes longer. It makes it more efficient. So if you try Laplacian, you might have a cooler form, but I think it's gonna take longer. So, but you guys will have to explore that. So yeah, you can see now it's a lot cleaner, and it's a very nice mesh if you look at it, because quad remesh, it's pretty good. It's not perfectly encoded because technically this should give me the whole loop right here, but it's kind of looping. You see, like the topology is not perfect because this loop should connect to this same loop, but it's actually kind of swirling around, which honestly, I mean, it's fine. You can still edit a lot. You can maybe get rid of some. So you see these edge loops, like that's kind of a small error that it made, because it shouldn't be doing it like that. It should be more direct. But for example, maybe like here it did it correct. So if you see the edge ring, it connects right. It's just that in some places like this one, you might not get that perfect topology that you're looking for, which is fine. Again, you can always remesh it again, change the target quad count, and you might get something cleaner. This one, for example, is quite clean. You can see the topology, you know, it wraps in a cohesive way. It makes sense the way it's kind of wrapping. I'm sure it could be more efficient, but this is quite interesting because then you could start playing with this, you know, kind of grabbing some more of these, and then just pretty much starting to create something out of it. Because I'm sure there's, for example, I can just keep grabbing this stuff. This, for example, so this whole thing. By the way, I'm doing this, I mean, there's a small sub-D tutorial that I have. It's an hour long, but it pretty much explains to you guys how to kind of maneuver around sub-D. But now, for example, as you can see, I have an isolated shape that I can kind of extract from this and pretty much just affect by itself. You know, like this in itself could be an interesting form to kind of play with. I mean, I'm sure that there's something to do with this. It could be inspiration for form finding, for architecture, anything. So there's so many applications to this script, honestly. It can be really fun, and it can be a lot of iterating step by step, you know, the way you find these different topologies, these different geometries. So yeah, I would love to see what you guys come up with by using this script. So I'm gonna have a Discord. If you guys want to join the Discord, go ahead. There will be a section where you will be able to share the ones that you generate, the spaceships that you generate, or whatever you generate from it. I mean, it could be spaceships, it could be products, it could be buildings, whatever it is that you enjoy. So you guys should join the Discord, follow us on Instagram, follow us on all the socials. You can always share it with me, stuff there. You can always ask questions too. You can show off what you found out, because I'm sure there's things that I haven't figured out. I mean, this is a quite complex script, so I'm sure there's some intricacies about it that, you know, it needs experimentation so you can actually find out what those things are. But my duty is kind of just to give you guys this tool, kind of offer it to the community, and then you guys will just show me what you come up with. I'm sure that you can come up with really cool spaceship designs, or you can like maybe extract really cool forms like this one, for example. I mean, I see a lot of potential in this for form finding, for different things, and for topology study even. All right, so hope everyone enjoyed this. Again, make sure to check this script out, and I'll see you guys in the next video. Bye bye.